Usually, in earthquakes and terror acts, there are not enough early responders, and if survivors are not detected quickly, rescuers will move on, leaving people to die because they are not spotted in time. We decided to determine the most efficient AI algorithm for a life-saving rescue robot that scans a building for victims and informs rescuers of survivors. We created several algorithms and tested their efficiency. We hypothesized that a flood field-based algorithm would be the most efficient in finding disaster victims. Other algorithms tested were random walk, biggest gap, and a modified version of flood field we created. To test the algorithms, we built a robot in a field with obstacles simulating a natural disaster scenario. We used the sonar sensor to see and avoid obstacles on the field. In order to see the robot's information about its environment, we programmed the robot to show scan results on the NXT brick screen and to draw a map of the already discovered area. The independent variable tested was the tested algorithm. The dependent variable was the number of survivors, depicted by red circles and counted in 10 minutes. The control variables were the field, starting point, amount of time, and robot model. The algorithms tested were flood field, the algorithm used by paint software to fill an area with color, biggest gap, the robot will pass between the widest space, random walk, when hitting an obstacle it turns a random amount of degrees, modified flood field with pathfinding. We scored 4 algorithms based on the average amount of victims found. The modified flood field received the highest score, a 4.7 out of 5. This represents a 151% improvement over the random algorithm. This video is one of its runs. The modified flood field algorithm was the best because it methodically searched the entire field. Since flood field can skip to a pixel on the screen while the robot cannot teleport itself, we had to modify a flood field algorithm to allow the robot to reach all undiscovered places. This is why the original flood field received a 0. We combined the simple flood field and a pathfinding to the nearest open cell detected going over discovered area. With the winning algorithm, our modified flood field, natural disaster and terror victims could be found and helped more effectively.